So I think on person. Geez, Alan was from the IGPJ, but I described it like the my 3 points back on the home. So we'll try to get started, everyone. Welcome to another week of Cyber Lab. Let's give it up. We'll do a quick set of announcements before jumping right into it. After today, I lost Salma a bit, but a couple announcements. The last event we'll have for this week is our first CTF of the quarter with PBR. If you want to come play with PBR, we're meeting this Saturday. From 12 to 6 in Engineering 4. The room is 63129. I'll post it on the Discord a little bit. Dead Face CTF is super beginner friendly, so if you want to come and you haven't played CTF before or just want to come check it out, this is pretty cool. Mark your calendar for this and yeah, come check us out. Next week for Cyber Academy, we have something really cool. We have a presentation by Vera. Vera is one of our members. She has a really cool presentation on OSINT. So if you want to come learn about, sort of reconnaissance, try to figure out how to social engineer people, then definitely come next week. Quick highlight for next week as well for Cyber Academy. One thing we promise all of our members is that the hacking you'll do in this club is real. So if you come on Monday, we'll be hacking a real student organization here at UCLA. So that's no joke. We are actually hacking real people. So if you want to come and participate with that, then come on Monday, same room, same time. That's really cool. Come check it out. Next week for Cyber Lab, we have a really cool presentation from Anderson about this hardware security vulnerability called Starbleed. It's a very interesting counterattack. If you want to learn more about hardware security, then definitely come next week. We have our first cyber social of the quarter next Saturday. We're going to the Santa Monica Beach. More announcements about that next week, but TLDR, we'll sort of meet at the Bruin Bear. If you haven't gotten your transit tap card from the central ticketing office, take like 5 minutes to literally just walk over, grab it. It's pretty chill. So, last announcement, NSA Codebreakers. This is a really cool thing we're sort of doing as an entire college. If you sort of want to try out these sort of challenges, we have a channel specifically for this. The way NSA Codebreakers works is that you sort of work on CTF challenges as part of you sort of represent your college. And so eventually, if more people in our college solve problems, we'll sort of eventually move up in the ranking. So we definitely want to get UCLA up there. So we need all of your help. Definitely join the channel and get the role to sort of help us sort of compete in this. Quick show of hands. Has anyone here not filled out the membership form? Okay, that's perfectly okay. Do you want to take a minute to scan the QR code? But this is good. We're getting there with most people filling out. Yeah, it just takes 5 minutes. Helps us stay on top of logistics. Very cool. We just hit the over 200 members mark, so that's a really big deal. That's like the biggest in our club history, so that's really exciting as well. Did you get the QR code? Okay, great. Does anyone else need it or? Okay, great. But yeah, without further ado, I'm gonna pass it off to Savannah for a really cool talk on this really interesting subject called machine unlearning. So let's give it up for Savannah.
Okay, yeah, as Benson said, I'm Savannah, and I'm going to be talking about machine unlearning. So what is machine unlearning? So machine unlearning is you take a already trained AI model, but you want it to forget certain data points it has been trained on. So for example, if you see here in this picture, I don't know if you can see it that well in the back, but this is an AI trained on faces, like facial recognition. So you have this data set, and you have this face that you want to forget from your AI. So you do the unlearning algorithm on this data point to forget it. And once the model has gone through the unlearning algorithm, it should act the same as a model that was never trained on that data point. So as you can see, this face is not in here. These models should act the same. So when you're doing machine unlearning, you also want to be able to preserve the model accuracy, and you want to have a way to verify that your unlearning was successful. So why would you even want your model to forget data in the first place? So there are a multitude of different reasons that I have listed up here. One of them is this concept called the right to be forgotten, and Mr. Cookie laws kind of like this. So the EU has a law called GDPR, which deals with basically like data security and privacy, and included in that is this thing called the right to be forgotten. So basically what that means is a user can request a company to delete personal data about them. So if a user requests for a company to delete their data, but the company used their data to train an AI model on it, then you can see why you might need to forget that certain data points. Additionally, there might be a civil liability having been trained on data. So as I mentioned or hinted at before, data can be very personal information. It can be things like medical records, your text messages, and other stuff. So there are privacy and security concerns about this data if it is leaked. So there's this thing I'm going to go over later in the presentation. It's called membership verification attack. So basically what this is you can see it's a technique to tell what data an AI model is trained on. So if someone can see what data you've been trained on and it has sensitive information, you can see why that would pose a risk that you might not want that to be able to happen. There's also an intellectual property aspect. So you might have all heard about like the controversy of generative art models having trained on artworks from artists without their consent or compensation. So being able to forget the artist's artworks from a AI would be a way to address that. And then lastly, there is adaptability. So say you train your AI on a set of data, but then, technology changes, the world progresses, and you realize that some of the data you used to train is now obsolete or not relevant. So instead of retraining the whole entire model, you just forget that part of the data, so your model still stays, still is able to use the relevant data. So why would you not just retrain the model in this case? Well, training a model can be really expensive. To train a model like ChatGPT, it can cost like around $4 million. So when you want to forget data, it's not always feasible to be able to just retrain the model on a whim. So now I'm going to go over some techniques and methods of how to implement machine unlearning. So the first one I have here is unlearning through fine-tuning. So what this does is you have your pre-trained AI model and you optimize it or train it even harder on the data you wish to keep, aka the retained set. So since you're training harder on the retained set, the model is more familiar and used to the data in the retrained set, so it's more likely to use that data and be able to identify it well than the forget data. So as an example, a model that can identify dog breeds. So you have a model that can identify a lot of different dog breeds, but then you wanted to forget about Chihuahuas entirely. That's your forget data. So what you do is you train really hard on the retained data, so all the dog breeds but not the Chihuahuas, so that when the AI sees a picture of a dog, since it's more familiar and more likely to recognize other types of dogs but not Chihuahuas, then you're kind of making it forget Chihuahuas in a way. So another way to implement machine unlearning is through CISA. Now, this is an acronym that stands for sharded, isolated, sliced, and aggregated. Like, I can see why they made this an acronym. So the way this works is you have to, before you train your model, so you haven't done the training yet, you kind of have to prepare for this technique of unlearning. So what you do is, like I said, before you train the model, you divide all of your data points into different shards or groups. And then you train mini models on them. So for example, an AI that can recognize food, you train a mini model on this food, on these foods, mini model on these foods, mini models on these foods, and then they all work together, kind of like a big model. When you feed the data to each model, like the different shards to each model, the data is sliced. So you feed it incrementally to the model and then save it. So for example, if you're training this model, you train it on the bread, and then you save the model, and then you train it on the eggs, and then you save the model. So when you unlearn, when you need to forget something, you only have to retrain the specific model right before the point you added the specific shard. So in this example, if say you want to forget cucumbers, because I don't like cucumbers, what you do is you go back to the point right before the model was trained on the cucumbers, so it's been trained on the carrots, and then you take that saved model and then you like basically retrain it but without the cucumber data. So that's how you do it. I feel like this way is kind of a little bit cheating because you are retraining, part of the model. But the thing is, since you're not retraining the whole entire model, it's less expensive and it's more efficient. And then I've talked about computer vision AIs, like recognition, but what if you have more of like a language model, something like a chat GPT, where you enter in a prompt to the model and then it spits back out a response to you. So there is also a way for this model to undergo machine unlearning. So I got this example from a paper, you can see from the graph, and you want a model kind of like ChatGPT to forget all about the Harry Potter series and books, have no knowledge of Harry Potter and who he is whatsoever. So there are 3 different steps of how you go about the unlearning. So the first step is that you need to identify, this is like an AI vocabulary, but basically in this context, we're identifying the words that we want to address. So you can think of tokens as words right now. So you do this by creating a reinforced model. So back here, what I said is for this example, you make a model that trains more on the retained set. So what you do for this example is the opposite. You have your original model, and then you have a new model that is trained really, really hard on the forget set. So this model is really, 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 really good with Harry Potter, and is more likely to bring it up than the regular model, since it's trained more in the Harry Potter data. So you see which tokens or which words have an increased probability. So for example, if you have your original model and you feed it the sentence, the scar on his, compared to the reinforced model, you feed it the scar on his, the reinforced model is more likely to pop up with forehead. Harry Potter has a scar on his forehead, so this is just showing how in different circumstances you're able to identify information that is more linked to Harry Potter. You're able to identify all of that. So then once you identify these tokens that have an increased probability come up in the reinforced model, then you do what's known as expression replacement. So you swap out the Harry Potter phrases for more generic phrases. So for example, if you have Hogwarts in your data, you don't want it to be there. You want it to say Mystic Academy so that the AI, doesn't talk about Harry Potter. So once you do that, you do fine tuning, which is basically the last step, implementing this so that the model's output matches the generic phrases. And then so if you look here, on this example, if you give your AI model the prompt, it was Harry Potter, the regular model, before unlearning, would say, oh, Harry Potter is the main protagonist in J.K. Rowling's series. You don't want that. You don't want to have any knowledge about Harry Potter. But after it's done unlearning, then it says it doesn't know what to say, so it just makes something up. Harry Potter is a British actor, writer, and director. That's not true. So you can see how this technique is able to make the model forget all about Harry Potter. And yeah, there are more examples on the slides. So now that you've done all this unlearning, That's great, but you want a way to be able to verify that your unlearning was actually truly successful. So one way to do this is through what's known as a membership inference attack. I mentioned this earlier in the presentation. So what this is basically this is a method that is used to attempt to see if a data record was used to train a model. Usually this is a bad thing, it's unwanted because you don't want other people to use this on your model to find out what data points you use to train the model. But in this case, in verifying machine unlearning, it's actually a good thing because if your membership inference attack can't tell that you used a certain data point to train your model, then you've successfully unforgotten the data. So, for example, you have this picture right here. I don't know, a dog with a watermelon. You want if your model was trained on this data, but then you went through machine unlearning to unlearn this data point, you want the membership inference attack to say that it has not been used to train the data, or been used to train the model. And that is all. Thank you for listening.
Are there any questions for Savannah?
A question on like the SISA unlearning part. Say like if you wanted to like say if you train all of the foods, but you wanted to unlearn like eggs, would you go back to before that? But then like say you did the carrots and cucumbers after you retrain on the eggs, would it remove the data from the cucumbers and carrots as well?
Like if you had a mini model that included like say these 4 data points, is that what you're doing? Yeah, so what you do is if you want to forget the eggs, like I said, say pretend these 4 are in one mini model, then you would go back to the point where you have trained it on bread, and then you retrain it on carrots and cucumbers, but you don't include eggs. So then, since you're retraining on these parts, you don't have to retrain on those. So it's like, does that make sense?
Yeah.
Okay. Does anyone else have any other questions?
Are there like methods for like grouping sizes, or is it done randomly?
What do you mean?
Like for each of the groups, you want like would you want to like mix like proteins together or something, for example? Like not specifically that, but like are there like methods for selecting the shards, or do you just sort them randomly?
You want like all the cucumber stuff, everything from one class to be in a model to train it, but the grouping of the classes, I don't think it really matters because I mean you're not going to be able to predict. You're asking?
I think it's a hyper.
Yeah, because I was thinking maybe like there might be some classes that like will train better together or something. I don't know.
Yeah, I mean it's up to the way that you want to train it.
Oh,
He's Argentine. All right, any other questions for Savannah?
oh no, that was.
Sounds good. Thank you so much, Savannah. Give everyone one more time. No, you have the same feedback form. So if you filled this out last week and you saved the URL, it's the same URL as last time. If you guys participate on the membership portal for ACM, the code for this week is at the end of the feedback form like last week. So if you want the code, make sure to fill out the feedback form. Thank you so much for doing it, just because we looked at the feedback from last week and we try to help improve for this week. And also, quick note, there will eventually TM be prizes for a lot of events for ACM. So if you want to sort of get involved with that, make sure to do it. Does anyone not have the link that needs it real quick for the next slide? Yes. What are the prizes? TBD. Allegedly, someone last quarter got a Xbox controller or something like this.
Without the Xbox or
Without the Xbox.
What? You have a summary with it?
Anyways, anyone else need the code? Break off into groups. One quick thing is we like to do social engineering time a little bit before we sort of break off into groups. So talk to your neighbor for a minute, ask, share, what's your favorite music artist right now, and then we'll sort of then break off into groups real quick. So yeah.
Hey, I've never met you. I remember you. How'd you know my name?